zone in a little bit and discuss biology with a bit of quite an emphasis on bacteria, fungi and carbon sequestration. So really this is my take-home message for today. Similarly what we saw with Gary's stool, the three-legged stool there, what I like to call the soil health triangle. Soil physics, soil chemistry and soil biology, all of equal importance to soil health and production. No one is more important than the other. Anytime we make a management decision, we need to ask ourselves, well, how will this influence the biology, the chemistry and the physics? All three should be in the forefront of our minds when making our management decisions. And what's very important is that they are very much interrelated and influence each other. So the soil's biological properties can influence the physics and the chemistry can influence biology and the physics, and of course the physics can influence biology and chemistry. So really summarizes down really, of course traditionally in the past we've lent quite heavily towards our understanding of soil chemistry, and that's been useful and fine, but we're going to kind of zone in a little bit here and talk about biology for me this morning. Now, just because I'm talking predominantly about biology today, that doesn't mean that it's more important than soil chemistry or soil physics. They're all of equal importance and all must be considered. But I'm just going to fill the gaps in a little bit here on the soil biology side. So, beneath the soil, we have a vast community of life. Soil's the second most biodiverse ecosystems on the planet, second only to coral reefs. So we have huge diversity of organisms and huge numbers of organisms. In a handful of soil, we have more living things than there are people on Earth or than people have ever walked on the Earth. So a huge community of life living in the soil, completely invisible to the eye, or for the most part, but plays a key role in the health and functioning of our soils. So we have a whole host of little critters living there. We're going to talk about these briefly. Algae, bacteria, fungi, protozoa, nematodes, arthropods, soil insects, and of course earthworms. And all of these organisms come together to form this community that we call the soil food web. Now, the key thing about the soil food web is that what drives the soil food web, the fuel of this soil community is carbon, is organic matter. It's the organic matter that starts this process. In that organic matter, of course, is carbon and nutrition and nutrients. And right here we have our bacteria and our fungi. They are our primary decomposers. Their key role in soil is to break down this organic matter, to feed on the organic matter, to incorporate the carbon and the nutrients in that organic matter into their biomass. So they feed that and incorporate the nutrients then into their biomass. And then as we move higher from there, then we start to move into the predators, so the organisms that eat other organisms. So these guys decompose organic matter, and then all these guys up here, the predators, well, they all eat each other, or they eat the bacteria and they eat the fungi for their nutrition. Now, what happens along each step of the way is that as the nutrients are incorporated into the microbial biomass, as those organisms die or as they are eaten by a higher level predator, well, nutrients are released and made available to the plant. So like all organisms, just like us, we consume food, we process that food, we metabolize that, and we excrete waste products. And it's exactly the same for the microbial world, and those waste products are nutrients that are available for plant uptake, organically complexed and available for the plant to take up. So there's all sorts of fascinating interactions within each of these microbial groups. Of course, there are thousands of different species, and they all can often do very different things, and they all react there to form that community.